Don't know how I feel about this one. I really don't. Why don't I know how I feel about it? In the 1960s, this was the absolute pinnacle of aviation technology. We hit a benchmark that we have never managed to hit again. Right, anyway. Let's go and have a look at the Speedbird. I've been obsessed with this aeroplane since I was a kid. And you know what? It's even more beautiful in the flesh than it is in all the videos and footage that I've seen of it. My God. How could we have retired it? How could we have retired it? So what do I know about it? It used a lot of fuel because of the speed that it flew at. They couldn't use massive turbofan type engines that we use today, so it's a pair of 4 very, very modified Rolls-Royce Olympus gas turbines. Oh man, the camera's just not picking this up. It is not picking it up. 4 modified Olympus jet engines. An amazing delta wing. You look at it, there isn't, it's like an E-type Jaguar of a plane, there is not one bad line in that whole thing. One of the cunning tricks they had to do, I think the Olympus is about 1 metre in diameter by about 4 or 5 metres long. Oh, and sorry, there's a French company that were involved with it. To get it into the air, I had to use a thing called an afterburner. So for these days, the engines were powerful. I can't even pronounce it. Sneka were responsible for designing, imagine standing underneath the wing of a Concorde. They were responsible for designing the afterburner in the back of the engine, so to get it into the air, there's still a lot of air, oxygen travels through a jet engine. To get it into the air, they put a big ring on the inside of it. Spray Jet A, paraffin. The tail just about as it is. Direct one into the exhaust, and that gives the thing about another 20% more power. Which is nuts. Absolutely nuts. And one of the, well, everything about it was a massive engineering challenge. One of the difficulties is the engines only work if the air coming into them is subsonic. But the plane flies supersonically, so how did they do that? Even the landing gear's pretty much. They used these massive big rams. This is before they had heavyweight computing. The rams moved it up and down to slow down the airflow to get it into the engine. The engineering behind it is just astonishing. Remarkable. I think we were doing that in the 1960s. As I said in another one of the videos, the Americans didn't like it. They kiboshed it. The Americans did not like Europe building European competition. They still don't, do they? They still don't. Right, let's go and look at some other engines. I've not checked that out, but that looks like a, it's got the General Electric logo on the side of it. So these are massive big commercial aeroplane engines. Look at the size of it. That's going to move a lot of air when it's spinning around. It's remarkable, isn't it? Yeah, if aviation's your thing, this place is great. We'll do one from inside the... We'll do one from inside Concorde in a minute. I'm going to hang up there. But I'm feeling all emotional. What a fabulous day. What an amazing thing. What an amazing thing. And if anybody doesn't know how these things work, the compressors at the front spin round. If you notice, there's a conical shape, runs up, so as the air gets pulled forward, it gets more and more compressed as it moves back. They've taken them away, but there's things called, these are rotors, I think, and they're stator blades. See them at the back? So the fans pull the air in, increase the velocity. The stator blades take out the velocity, but increase compression. So air pressure just constantly gets greater as you move back. At the top, some air travels over the engine. You get thrust out of that, but it also is there to cool the actual engine. So that's the primary low pressure compressors. Intermediate compression, probably. The pieces of metal here are called flame cans. That's where the fuel's injected. Oh, camera's not picking up it. So the fuel gets injected in these things. You can see there's holes in them to allow air in for the combustion. The fuel cans then fire into the last part of the engine, which is the turbine section. Turbine section spins, and there's a shaft, sometimes two, sometimes three, runs from the turbine back to the front of the engine. They're usually started with compressed air, what's this? Rolls-Royce Conway. They're usually started with compressed air or a gearbox driven. So air comes in, squeezes it down. A lot of air travels round about the outside of the engine to stop it melting. The flame cans inject the fuel. That hits the turbine section. Turbine section spins round, and that's connected to the front. There you go. But you already know that, don't you? Right, let's go and have a look at the inside of Concorde. The basic core design in that engine is similar to the basic core design in this engine. The difference is these massive compressor blades at the front. That generates a thing called bypass air, which travels round about the outside of the engine again to keep it cool. But it acts like a propeller. So the air travels back from here round about the outside of the casing, cools the engine down, comes out the back of the engine as it was. There's a name for it and I can't quite remember what it is yet. A ducted fan. A ducted fan. That thing's about 6 feet wide. Anyway, we'll hang up and have a look inside Concorde. I hope you're loving it as much as I am. What a beautiful bird. Beautiful, beautiful thing. Smashing.